This is part 4 of how to build and code a VFO. If you'd like a PCB that we are using in the project, and if you want to get closer insight into the parts reviews and where to source them from, wait to the end of the video or check out the end of the video and I'll go through everything in more detail there. Okay, so if we move down to this section, and we've got RXTx Display enable. So this simply means, do we want to see if the radio's in RX or TX mode on the display? So yes, we do. So let's just change that to true. Okay, and if we move on to the next section, which is TX8 shift enable. So what this is, this shifts the local oscillator frequency when we go into transmission mode. So when you key the mic, it will shift the frequency. Obviously on a Cybernet unit, it doesn't do that. It stays at the same local oscillator frequency. So we leave that, we're going to leave that false. But if we wanted to shift the local oscillator frequency when we go into transmission mode, we would make that true, and then below it here, TX8 shift hertz, we just put the figure in here, and as before, we can either make this as a positive or negative value. Okay, and if we move down to this last one here, this is mode shift TX enable. Now, all this is just means that when we go into transmission mode, do we still want the shift, the mode shift on the local oscillator? So, you know we are reducing the local oscillator frequency here on lower sideband by 3 kilohertz, so we reduce it by 3 kilohertz, and all this is do we want it to do it on the transmission as well? So when we go into transmission mode, you key the mic, does the local oscillator frequency still want that shift? And we do want that, because that's the way a Cybernet superhet works. So yeah, we leave that true. I've put these options in here simply because it may be you may want the output from the clock generator to generate a direct frequency for transmission. You would reduce the frequency at this point by the IF, and that will give you the direct frequency. So you can play around with it. I know it's a bit of a thing to get your head around. I do have a video on Superhet Basics, which is based on a Cybernet. I did it on a Cybernet. It's a very common design. So if anybody you want to look a bit further into it, then have a look at that. It's a bit of a thing to get your head around. It is up conversion, down conversion. We're adding down conversion, we're adding the frequency. On up conversion, we're reducing the frequency. It all becomes a bit of a head swelling thing. So, but once you get your head around it, it's not too bad. Okay, so let's set the rest of this up. So if we change the IF frequency, because our Cybernet is at 10.695 megs, so we'll put that in hertz. I think that's right. Let's just double check. Yep. And we come down to here, and up down conversion. So it's a down conversion radio, which means that it adds the frequency you want to receive onto the IF frequency. Yeah, I know, but it's just how these things work. Okay, and that's basically it. We're all set. Now I've got this connected up to my frequency counter. We'll take a look at that in a second. Okay, so now you'll see, where's my little pointy thing? Right, so we're now displaying RX, and the band, where it said band there, is gone. And it's simply because there isn't enough space on here to put the modes in as well. So on this cable here, this wire, that's going to ground, and if we look on the circuit board here, we've got ground, AM, FM, upper and lower sideband and carrier wave. So I've got a 5-volt power supply, so if I take the green wire, which is AM, it's displaying that we're in AM mode. And if I take the yellow wire, let's just get this one, that should be FM. It is indeed. So these just go into your radio equipment. You may be building a radio equipment. So as I say, anything over 5 volts, 5 to 16 volts, it will register. And if we look on the white wire, that's upper sideband. And the grey wire is, oh, that's carrier wave. From this one, yeah, orange. So that should be lower sideband. Yes, it is. Okay, so let's set the band. So we're doing Cybernet, so let's set the band to the 11 meter. So it's 27 megs. What we should be seeing is 10.695 megs, which is our IF, plus 27 megs. So let's take a look at the frequency counter. Okay, it's all looking a bit Heath Robinson. So we set to 27 megs, 10.69 is nearly 10.695 megs. They do drift a little bit, these, because of the crystal oscillator. Obviously, you know, as we said before, I've made a video about it, they need to be calibrated. You need the calibration figure. So if I hit the AM, you can see it's registering AM. The frequency is not shifting, it's the same. The other ones, yeah, the upper sideband, if I can get it on there, yeah. So what happens if we hit the orange one now? That's lower sideband, that's the one we put the setting on. Yeah, you can see that's shifted by 3 kilohertz. Comes back. Yeah. Okay, and incidentally, if you put 2 of these on at the same time, you get an error. So if we just put 2 on at the same time, you see it says error, and it shouldn't be frequency shifting. No, it's not. So if for any reason, you know, you see that, that is simply because you've got 2 coming up at the same time. You need to have them separate, otherwise it gets confused. And of course we've got the TX, which is the brown wire. I didn't show you that, so that should be switching from RX to TX. Yes, it is. Okay, so let's look at this display. So we've got an 8-digit 7-segment display. We've also got stops on here. And if we turn it over, you can see we've got a driver IC on here. Now this is Maxim 7219. And if we look here, we've got some connections. So we've got VCC, ground, D in, data in, CS, which is its client select, and the clock. Now, essentially, this is using an SPI interface. Now, we spoke about I2C interfaces, which was developed by Philips. SPI essentially is a 4-wire system, even though we're not using 4 wires on here. And it's quite a fast interface compared to I2C. If we look on the circuit board here, we've got VCC, ground, D in, CS, and the clock. And obviously this just literally connects straight up into here. We have to do a bit of configuring in the code. Now I'm going to use a little header, and that should, all things being equal, just fit in there. Yeah. So we'll get the header on there, and I'm going to connect up between the header with a ribbon cable. Now I buy these pre-made. They're really cheap, and it makes for a really tidy job. I've already soldered standard pin header in here, but I could put a JST XH series, and I could put it on the back, and you know, then you could mount that, you know, in an enclosure. Also, another thing to look at here, you see we've got VCC ground and D out, where on this side we've got D in. So if we're going to supply it, we need to hit this side where the data in comes in. But what this allows us to do, we can cascade these, so you can put another one on in. So if you've got two VFOs, one could display one VFO frequency and the other will display the alternate VFO frequency. I'm going to solder this in, we're going to get this connected up, and we'll take a look at the code and we'll see if we can activate it. Okay, so the first thing we need to do is go to libraries, and then we do a search for LED control, and this top one here, I'm not even going to try and pronounce that. Yeah, it's the library for the Mac 7219. This is the one I'm using in the sketch, and you just literally hit install. Now I haven't got an option to do that because it's already installed, so you just hit install, and then we'll move on to the next stage. If you look here, obviously between the bars, as I said before, this is a user definable area. Now you can see these forward slashes. Now this comments out sections of code on that line, so what happens is if we put two forward slashes in there, it just simply means the compiler will just ignore that and then move on to the next line. So if we uncomment that there, this says define max 7219, so that'll activate it. Now just be aware, the more functions that you switch on with this microcontroller, the more work it's got to do, and it's an 8-bit AVR microcontroller, so you know, if you're not using these functions, don't comment them in. But that's it. That's it. It's now activated. Okay, so let's upload that to our Arduino. Bingo jingo. We have got a display. So let's have a look. Sorry, I'm coming away from the mic. Okay, and there's another thing we can do. So in this section here, it says LED brightness. Now I think we can give this a range of up to 8. So let's increase that to 8. And then upload that to the Nano. Yeah, that's significantly brighter. Now, it doesn't seem to come out very well with this camera, but they're really nice coloured reds, and yeah, that's very bright. Okay, so we had a number of questions, one of which was, can we put bigger displays on this? Well, the answer is yes, but obviously there's limitations. Using this microcontroller, you know, we're pushing the boundaries, even using this screen here. Now this has got an SSD1306 IC in there, and the resolution is 128 by 64. They actually do work quite well, but the problem is the Nano has to keep paging all that information over the I2C bus, and consequently it doesn't update that quickly. But you can get these LCD displays. This, I can't remember how many rows this is. I think this has got 4 rows, and they're just dot matrix displays. They don't look great, however you can get a lot more information on these, and it's a lot less taxing on the Nano. You can also get OLED. This is 2.4 inch, and this one is an SPI stroke I2C. Now if you're going to use it on I2C, I really don't recommend you buy that, because you have to convert them and they don't kind of work properly. They do, it's just that it needs a reset. So we need to connect to a dedicated reset pin to make it run on I2C. And there are There are displays that don't require that, so they just plug straight in. Now you can get them in a variety of colors as well. And then we can look at, you know, there's things like these TFT displays. Now this is, what's this one? 240 by 320. Now these work incredibly well, but there's no way on earth that this Nano is going to be able to drive that. It just simply doesn't have the power. Now, you know, it's not everything. I mean, I actually like these Arduino Nanos. Well, this is a clone, but I really like them. There's a lot of things on there. They work incredibly well, and they're very, you know, they're very cheaply priced. I mean, you can actually buy the IC, and it's an Atmega 328p. I can buy them from DigiKey for about $1. So they don't cost much, but they are getting on. That's the problem. They're getting old. You know, and obviously technology's catching up, so hence why I put the option on here to put a much faster microcontroller. So obviously this is the ESP32. In fact, they both are. Now these are S3s. Now there is a slight difference between them, which we'll go through later, but I've designed it around this one, and yeah, it's like night and day. This is a 16 meg clock frequency, and it's an 8-bit microprocessor in there, and it's got limited flash memory and limited RAM. You know, and if we look at something like this, the ESP32, it's got a clock speed of 240 megs. It's a 32-bit. In fact, it's got dual core CPUs in there, and yeah, consequently, it's a better performer. So yeah, displays, if you know, it's to do with how much grunt you've got in your microcontroller. But yeah, for the Nano, I haven't written the code for this, but I will. You know, I think these are great things. They're very cheap, and of course they're I2C as well, so they just plug that onto the I2C bus, and you see I've actually put a header in here now, so yeah, I'm raring to go. Okay, so I'm just going to remove the power. We'll just pull this bad boy out. And then we'll put this one in. Try to. Okay. If we add power, it's come up against running the same program. Now we've got a little Neopixel on here because we're sharing it with the GPIO, but you can see how fast this is updating. It updates a lot quicker, and you know, there's less jitter on when you tune in from the SI5351 as well. Now these things are, you know, these things come with Wi-Fi as standard. It's also got a Bluetooth connection, so this little thing you can see sitting on the back here, that's an antenna, so you can connect this to your Wi-Fi. There's a lot of things we can do with this, and there's a lot of possibilities. It's got a ton load of RAM in there, a load of flash memory. It's like night and day when we talk, you know, with the Nano. However, they are more expensive, so, but not that much expensive, you'd be surprised. So, but that, yeah, you can see that's really, you know, updating that screen much faster. Okay, and if we disconnect that, and let's try with this. Okay, let's just pull that off because we're getting a lot of glare with it. Okay, let's reconnect. So as you can see, we've got, you know, there's a lot more we can do with this. You can see we've got a color bar graph display. We've got all the buttons as we had before, so we can change our tuning steps and speed. It's a lot more you can tell it's a lot more active. Now, obviously, you can see it's doing its thing. All I've done is just got some random numbers and I'm sending some information up there. I'm still writing the code for this. It will be available to download. And yeah, so this one's got dual VFO, so we can go VFO A or B. So you can change the so you can switch between them, and obviously it stores the information. So if it comes back, now this one works a lot better. Now I'm still doing work. I don't really like this font on here. I think I can do a lot better, work with that. But again, it all takes time. These things all take time. So as I get the time, I'll be able to program it. But this one will display time as well, UTC, and it'll get it. I can get that from Google over the internet. So we just set the Wi-Fi up, and this will give us very accurate UTC timings. And look at also, put your own time in there. Just do a correction from your time zone. It's pretty good. I don't know how well you're seeing this, but it does look impressive. Now these screens, funny enough, are a really good value, and again, this is working on SPI, so it simply, I can send a lot more information up there. Now there's a bit of an art to the programming, but there we go. Now there's other things we can put on here. I'm going to put the memory functions. I'm going to put a lot of other usual stuff. But it simply means if you're building radio equipment and you've built a receiver and transmitter, if you added something like this will turn it into a fully operable radio. And the other things we can do, I can write the code so that things like Ham Radio Deluxe can communicate with it. We can communicate with it over the Wi-Fi and control it and pass information. That's not, it's not a problem. Let's have a look. Where's the bands? It's here. Yeah, it does perform quite well, so. Okay, well, I'm going to go through the parts where you can source them in detail like I did last time. I know people found that helpful, so that'll be coming up at the end of the video. But yeah, it's going to take time. I'm not going to make any more of these how to build and code. I think it's run its course. But I will make more videos on the band surfer. So if you see band surfer VFO, and as I sort of populate the various sections and get them working, I'll make the videos. And again, I'll share the code if it's if people are interested in building it. The code and schematics, as we said before, are available to download from the description. I'm also setting up a GitHub page. I've got an account. I just need to configure it, and then what I'll do, I'll put all the revisions of the code on there. Now, as we said before, the ESP32 code is still being developed. It should be out in a couple of weeks. We want to add more features to this. I know the 11-meter aficionados want to channelize it, which we will do. We'll also add RIT functions on there. And if you've got any suggestions, just ideas, useful features, and I will try and include them. If you are into coding and you want to get involved, yeah, great, super. Just drop me a line. There's an email in the description, and it would be great to get other people on board. And if you would like one of these printed circuit boards, they are currently available. I'll leave a note in the description if we run out. However, just send us an email. There's an email in the description, and just put in the subject line Band Surfer PCB, then we know what it is. And obviously put in your location. We're happy to send overseas, and my daughter Evie will quite happily send you one out for a small charge and postage costs. And as before, we're going to go through obviously the parts just now, obviously what we've been using. Now, obviously, as I said before, we haven't released the code for the ESP32, but it will come out in a couple of weeks. But I'll cover those parts as well for the features that, you know, we didn't go through. We will go through these features as we put it together. Okay, so as previously, the parts list is in the schematic on the left hand side here, and in the previous videos we've covered this basic setup. Now most of these parts are just general generic parts. I've tried to put a bit of description in there, you know, such as electrolytic capacitors, the lead spacings, if you want to get them to fit properly. It's not that important, to be honest, but yeah, it's there. But these are generic parts, so I'm not going to go into any detail on that. You should be able to buy these from just about anywhere. Okay, so we went through, as I said in previous videos, and we looked at various parts on here, so I'm not going to cover that. The links will still be in the description, so you know, they're affiliate links. We use AliExpress, we get a tiny commission, and what comes back goes towards the channel, and it's much appreciated. What we're going to cover in this section is the ESP32. This is the S3 N8R8. Now there's a lot of variations on the ESP32, so we'll look at that in some detail. We'll take a look at the MAX 7219. This is an 8-digit 7-segment display. And if we come down the bottom, we'll take a look at this FRAM module. Okay, let's talk about the ESP32. Now this is the S3 model, this is the N8R8 module, this is the one I'm using in the board. You can use the Arduino IDE to program this. It's just that you've just got to map all your pinouts. Now these are appreciably faster, as we spoke about before. This has got a 240 meg dual core processor in there, and obviously that's reflected in the price. Now this is a good price. If you actually look on Amazon for this same board, it's a lot more expensive. So I guess these Amazon sellers probably get the bits from here, I don't know. So let's come down. There's a thing we've got to pay attention to. So this is, if you see between the pins here, the width between the pins is 21.8 mil. Now there is another board that will work. It's identical, you know, to the way it works. It's just physically different, and that's this one. Now I've left the links for both of these in the description. This is half the price, and if you were going to select this, you want to select the N16R8. N16R8. So it's got exactly the same number of pins, but if we come down, we look between the headers here, and this one's 25.4 mil, which is wider. Now you can get these to fit if you're using female headers on the board. That's providing you're using the board I've supplied. You can bend the female headers out and then bend the pins in on the microcontroller, and it will fit. It's not ideal, but it'll work fine. So if we get back to here, it's available without pins. I think it comes with the pins. It just they're just not soldered in. And this one is with the pins soldered in. And similarly, if we come over to here, you get the N16R8 without pins, and then the other one, it says with pins. It just says weld. It just means it's soldered in. So if the N16R8 is welded, that means it's got the pins sort of pre-soldered in the board. Now if we come down, there's a lot of features on these. These can do a lot of things, and you know, I'm still exploring it, and there's a lot of features on here. I'm not going to go through them in this video because it's a video on its own. But as I say, the Arduino IDE will work with this. There's a bit of trickery. You've got to play around with the IDE to get it to work. So once you've set it, it'll just work every time. I'll make a separate video on how we configure the Arduino IDE to work with these. Now these are made by Expressive from Shanghai in China. That's the manufacturer, and this is their development board. Just one thing to consider with this board, this is the N16R8. I have noticed when using the band server PCB, when we've got an external power supply plugged in, it does create a conflict with the USB, because obviously that's supplying 5 volts as well. It'll come up with an error. We don't get that with this board, and simply because that's what I've designed the PCB around. However, this does work. It just means that you don't run the power at the same time, the external power, or you will see errors. And one other thing, if you look down, you can see you can get these even cheaper, but these are slightly different. I haven't tested these, so they look better value, but again, I haven't tested them, so I can't really sort of recommend that board. Okay, so let's have a look at the LCD screen, the color LCD screen. Now, you can get these in various sizes, and there's quite a number of things with them. Now, the one I'm using is a 2.8 inch, and it says no touch. Now, these screens come with 2 options. Obviously, you can get a captive touchscreen layer on the top, and the other ones, you know, are literally just a display, and they don't have the touchscreen. Now, I'm not using the touchscreen facility on this, so hence, you know, I've used the no touch. But you can use the ones with touch as well. We just simply don't connect to those points. Now, they're available in a number of sizes. Now, the one I'm using is 240 by 320 pixel at 2.8 inch. And if we come down, we can see the details of each board. So, okay, so the one I'm using is 2.8 inch. And if we look carefully at this section, we've got VCC ground, we've got client select, we've got a reset, DC, SDI, SCK, which is clock, LED, now that's the power to the LED backlights, and we've got MISO. Now, we use these connections to connect into our microcontroller to display the board. Now, the ones up here, these are for, this is for the touchscreen, so it's the information going back. I'm not using it. And as I say, you could get the touchscreen ones, it won't make any difference because we just don't connect to those pins. And there's some other, I know it's upside down, there's some other ones here, connection points, and basically what these are for, you can actually put an SD card in here and save information. And again, I'm not using that function. But they come in various sizes, so if we come down, we've got 3.2 inch, and that's also 320 by 240, that's what I've got it configured to. And if we come down 3.5 inch, then it jumps up to 480 to 320 pixel. Now, I've actually ordered a 4-inch one, I'm waiting for it to arrive. So you can get a 4-inch model of this, and that's in that size format. So I'll have to modify the code to accommodate that. We can get more information on there as well. I haven't tested this, but I'm pretty certain, judging by how the other ones work, this should work fine as well. Okay, so let's look at this I2C FRAM module. Now, this is based around the MB8 5RC256V IC. It's a little 8-pin device, and they are manufactured by Fujitsu. Now, I think these are really cool because, you know, years ago when we wanted to save information, we used to do it using microcontrollers and some SRAM, and then the SRAM would need a battery backup. And when the battery goes flat, you lose all your information, and so it means you have to maintain it. With this, you don't. FRAM simply stands for Ferroelectric Random Access Memory, and it's ideal for these kind of projects because it simply means that you can sort of save all your settings and switch the unit off and switch it back on, and it'll come back exactly as you left it. Okay, so if we look here, this is the data sheet. This is from Fujitsu Semiconductor, and it goes through all the information here. Now, it's a 32 kilobyte unit, which is 256 kilobits. Now, I think this is really good Because the other options we've got is EEPROM, which is electrically erasable read-only memory. Now there's problems with that because it's quite tricky to keep writing to it. Also as well, you've got very limited write cycles. So the one I'm using is this. You can get it from AliExpress. It's got the correct IC on here. And it literally just connects up. And on the pins, we've got VCC ground. We've got WP. That simply means write protect. So if you've got information on there and you don't want anybody overwriting it, you just simply, I think you take it down to ground. SCL SDA, which is our I2C, and we've got A0, A1, A2. This is simply for changing the I2C address. So if we've got a conflict on the system, we can actually change the I2C address of this device. Now these work incredibly well. The code isn't written for them yet. I have been using them in other projects. I have got the code, it's just I need to implement it into the system. I'm not sure whether I'm going to be able to get this onto the Arduino Nano. I may be able to. I'm going to certainly try, but it certainly will work with the ESP32. Very reasonably priced, and yeah, I think it really turns your project into something else. Once you've been operating and playing around with radio equipment that you've built yourself, you'll find this is incredibly useful. It's like a godsend. This is the LED display that I've been using. It's based around the MAX 7219 IC. It's the LED driver, and these are pretty retro looking, I think. I actually quite like the look of them. They'll work either on a 5 volt or a 3.3 volt system. So it'll work with the Nano, and it'll also work with the ESP32. Now, it's very simple to connect this into the board, as we went through before, onto the band surfer PCB. You know, it just fits like for like. And as I said, these are cascadable, so you can put another one just literally connected on to the other side of the board. So we've got D in and D out. So D out goes to D in on your second board, and we can simply put that in the code, and if you've got dual VFOs, it will be able to display that. Now I'm not quite sure I'm going to manage to get 2 VFOs on the Nano, but it will certainly work with the ESP32. Okay, and finally, I just thought I'd show you this store. It's the Mayway Electronics store on AliExpress. Now, I've bought a lot of stuff from these guys. I find them really good. The products are good quality, so I do recommend them. And they're reasonably, you know, they're really well priced. And this is the sort of place you can get all your cables if you want ready made up cables, or header, or you know, such like for making up your circuit boards. It certainly makes a nice, neat, and it looks a really professional job using this sort of thing, you know. So if we go to products, say look at wire, everything I've based this around is XH series. So the pitch we're using is 0.1 of an inch, so it's 2.54 millimeters. So if we click there, you can see we've got ready made up cables, and if we click into here, you can get these at various lengths. So these are like ribbon cables, and it's just, you can adjust the length here, so you can 20 centimeters, 30 centimeters. Obviously the price will vary accordingly, and how many points, you know, or how many way the cable is. And these are for 10 units, so obviously it does go up in price. So 12 way 10 units, yeah, works out 47 cents per unit. But if you come down to the smaller ones, it's a lot cheaper. And if we go back, yeah, you've got these ones made up with the cables, you know. So yeah, everything I've used is XH series. And if you look under connectors, you get the headers, so you can get the shells, and you can also get you know, the male pins. You can get them at right angles. They've got just about everything on here you could think of. So I can't recommend these guys highly enough. and there's some really interesting stuff on the site. Now, I didn't get my crimp tool from here. I actually got that off Amazon. I'm not sure, they probably do crimp tools on here, but again, if you go to use the XH system, make sure you get a crimp tool that covers XH series connectors. Okay, well, I'm going to end the video here. I think, you know, from when we started, a lot of people are asking how to build a VFO. I think I've given you enough tools and direction, and I hope you found the videos interesting. I've certainly had a lot of fun making them. As I say, I'm not going to make any more of this series. I will do some on the band surfer, and I'll make the code available as well. So keep checking the descriptions, because as I update the code, I will start putting it in the description of part 4 as well. So just periodically check that. And as I say, I'm going to set up a GitHub page, and I'll put those links in there as I get them. So happy constructing, and we'll see you in the next video.